One of the things I kind of regret about the way I learned calculus was how quickly we went from limits right into derivatives. Now, I get that using limits and using the equations involved with limits to find derivatives, those equations get very complicated very quickly. And so I understand exactly why you don't want to spend a whole lot of time with limits just because it's so much easier once you learn the rules with derivatives. The problem is I didn't understand the concept of limits, and that kind of limits your ability to really understand what calculus is doing for you. And so just a brief explanation of what's happening with limits. Let's say we have a car that's 1 mile away from the house, and you're controlling your speed enough that every second you're making up half the distance between you and the car. So you start off at a mile, and 1 second later you're at a half a mile. So you've got a very exciting second there because you're going pretty fast. But at a half a mile, then the next second you're gonna cut that in half. So now you're going you're a quarter of a mile to the house, and every second you're just having that distance. Now, at first you're going extremely fast. It doesn't take very long before you're going extremely slow. And so the question is, how long is it going to take before you hit the house? And the answer is never. You'll get pretty close to the house, but you'll never reach the house, and you'll never reach the point where you're no longer traveling. And so if we would look at that as a limit. If we have, for example, the distance between you and the house is equal to 1 over the time times 2. So however many seconds times 2. As t gets bigger and bigger and bigger, the distance between the house is going to get smaller and smaller and smaller. But by definition, you're never going to reach the house. But you can take the limit as t approaches infinity, and it's pretty easy to see what happens. The more time you spend, the closer and closer you're going to get to where that distance is going to equal 0. Okay. Now, will you ever reach that? Nope. Mathematically, it's impossible for you to reach that, but you can see pretty easily that that's what you're approaching. And so what we're doing when we're taking a look at limits is we're looking at, well, what's happening around it? Can we see what's being approached as we take the limit as one number approaches another, and especially as one number approaches infinity? In simple terms, there's times where you can take the limit of something that's actually pretty easy to solve. So for example, if we were to take this equation, and let's say we're just going to solve this equation, let's factor the top. We get y is equal to x minus 7 times x plus 1 all over x minus 7. Now we can solve this by canceling out our x minus 7. X minus 7 over x minus 7 is just equal to 1. So we get y is equal to x plus 1. But according to our original equation, x can never equal 7 because then we get a 0 in our denominator and it becomes undefined. But if you look at the graph of this, I'm just going to do a rough graph here, but the graph is going to look something like this. But out here at x equals 7, we have this no solution, and so that would be an empty point there, but x can't equal 7. But it's pretty easy to see that coming from both directions, as we get closer and closer to 7, if you plug 7 in here, we're approaching y equals 8 here as x approaches 7. So sometimes it's very, very easy to see, but it allows us to evaluate what's happening when something might not be easy to see or is undefined at a certain point. But it's important to be able to take a look at what's happening as we approach these undefined limits, or as we approach infinity. Infinity is not a number. Infinity is a concept. But as we approach infinity, we can see what's happening to a specific equation. And it does allow us to evaluate things that we wouldn't be able to evaluate otherwise. So, as you work with limits, don't spend a whole lot of time. It's important that you understand how limits help us find derivatives, how they help us to integrate. But it's more important that you understand the concepts behind limits that allow you to do what you do so that calculus begins to make sense. calculus kind of becomes its own language. And so we tend to throw out some of the basic math concepts because they don't always feel like they fit in because we're using different language for them. But if you're understanding what's happening as you approach calculus, it makes it much easier to understand and put things together that you would not understand otherwise. So if videos like this help you, please like and subscribe. Pass this information on to anyone that you think it might be helpful for, and thanks for watching.